In 1972, the first Landsat satellite was launched into orbit, ushering in a revolutionary new era of Earth observation. More than 50 years and 8 satellites later, the Landsat program has collected an immense amount of data that's proven an invaluable resource to scientists studying the complexities of our planet's surface. The abundance of data provides insights, but it can also pose a daunting challenge for researchers to extract and analyze information. Landsats 8 and 9 alone each gather close to a terabyte of data per day. Enter artificial intelligence. AI's popularity has taken off in recent years, with new tools that allow users to generate imagery, transcribe audio, and even compose music at the click of a button. This is nothing new for the scientific community, however, which have been using artificial intelligence methods for decades. When it comes to working with Landsat data, one of the most popular AI tools is machine learning. Machine learning is a subset of AI that can train computer programs to recognize patterns and analyze imagery, skills that prove exceptionally useful in the application of Landsat data. In fact, when combined with Landsat, machine learning models have led to a number of advances across a variety of scientific fields, granting further insight into our planet's past, present, and future. One of the major challenges of working with satellite imagery like Landsat can actually be found up in the sky. Clouds. Obscuring Earth's surface and casting shadows that reduce visibility, a cloudy day can be a downright nuisance when it comes to analyzing certain satellite imagery. Pinpointing these clouds helps to improve data quality by removing noise and artifacts, making it easier to detect changes over time. But while accurate cloud detection across a massive dataset such as Landsat's would be a tall task for anyone human, it's a piece of cake for a computer. In 2019, researchers from Oregon State University constructed a deep convolutional neural network model, a machine learning tool that excels at recognizing patterns in imagery. With the help of existing Landsat 8 data, they taught their neural network to automatically detect clouds in satellite imagery with an amazing 97.1% accuracy rate. The researchers believe in the future, cloud detection algorithms like this one could even be harnessed to identify clouds across the entire Landsat 8 archive. Machine learning's benefits don't just end when the clouds clear. Down on the ground, there's plenty to keep an eye on. Our planet's one constant is change. Earth's surface is perpetually evolving due to human and natural forces. Landsat's ability to track these changes over time has proven to be an incredible asset to the scientific community, especially when used in concert with machine learning. For example, researchers from the University of Texas at Austin used Landsat data with a random forest classifier, yet another type of machine learning tool that combines multiple decision trees to make predictions. Using data from Landsats 4 through 8, they used the classifier to map changes in land use in northwestern Belize from the 1980s to the present. The results showed that tropical forests and wetlands that don't have a designated protection status are increasingly vulnerable to deforestation due to Belize's expanding industrial agriculture. By combining these new advances in machine learning with Landsat's capacity for looking back in time, researchers believe in the future, this approach would make it possible to provide robust estimates of deforestation in Belize. As climate change drives our planet's temperatures higher, so does the prevalence of extreme events that put ecosystems at risk. Wildfires across the globe have increased in frequency and intensity. Australia is no stranger to these types of fires. The 2019-2020 bushfire season was one of the most destructive on record. Using satellite imagery to pinpoint when and where wildfires are burning can be an important tool for assessing damage in future fires. Researchers at the University of Western Australia developed a new machine learning approach with the help of Landsat 8 data to generate a 16-year history of wildfire severity in the eucalyptus forests of the continent's southwest. They fed data gathered by satellites, including Landsat 8 in 2005 to 2020, into a supervised classifier, a type of machine learning algorithm that learns to classify data based on labeled examples provided during training. By teaching the algorithm with examples from the past, this method of machine learning could be used to predict the severity of future wildfires, critical data that could aid in the management and conservation of Australia's extensive eucalyptus forests. These are just a few examples of the remarkable ways Landsat data and machine learning tools are unlocking new possibilities for understanding our planet. This combination has already led to significant advances in agriculture, forestry, urban planning, climate change research, and more. As more satellite data becomes available and machine learning techniques continue to improve, so too will the potential for applications in additional fields critical to the health of our planet's ecosystems. In tackling the complex challenges of today and tomorrow, the blending of Landsat data and machine learning will be vital to help people make better decisions to protect our planet.